the point, I gotta let it all get it out of their system so I can talk. Of course, the point of this question is to remind you that the surface area of a cylinder is super easy, 2 pi r squared plus 2 pi rh. But if you did that, you of course got the answer wrong because there's no paper on the top or the bottom. So you just needed the 2 pi r squared and the 2 pi rh. And then of course you took that number and multiplied it by 100,000 to find out how much paper gets used in the day at the factory. And then I asked you to estimate how much of the classroom walls could be covered. And I said the wall goes up to that beam that goes over there. The walls are, Nick gave us a good estimate for the walls. He said they were 25 feet along the ground for both. Yeah, he went in feet. That's cool though. 25 feet. And he said they were 12 feet tall, right? Which means, and how many walls are there? 4. So you would have to multiply that by 4, right? But there's a problem with that because the paper was in what units? The paper was in metric, yeah? So what you needed to do was get these into centimeters as well, right? So if you change 25 feet and 12 feet to centimeters, you would have known what to do, right? So if you did 25 feet and you remembered that you wanted centimeters, so it was 30.48 centimeters equaled 1 foot. So it was 25 times that, and then 25 times 12, or I'm sorry, then 12 times 30.48, and then all of that times 4, you would have had the walls, right? Everybody cool? And then whatever that answer was, you would have divided it by your answer in A, and that would have gotten you the number, right? So it just depends on what you used for numbers. If you didn't use 25 feet and 12 feet, then you would have gotten something different. But the whole point of the question was that you estimated. So you looked at this wall and you didn't say, well, that wall is 3 kilometers long, right? That was the point of this. That's why I said estimate and why I didn't give you anything with which to measure. You were supposed to estimate. Okay? How could you have estimated? Well, some of you actually got up and walked across the room and counted your steps, remembering that a step is about a meter. And then you looked up to that beam and you compared it to this wall and you, whatever, right? It was however you were supposed to figure it out. I am interested in the math. Understand? That's why I asked for explain your reasoning. What did you do? So if I was explaining this, I would have said, well, I estimated the room was 25 feet square and the walls were 12 feet tall. So it was 25 times 12 times 2. Then I converted it into centimeters, multiplied it by 4, and divided it by however much I had, right? That's what I was looking for. Now we got to the bike. Now, I've always liked these bikes. I think that those bikes should be in the X Games. Because if you could do crap on like the X Games on that, that would be hardcore. Of course you would. All right. Then you'd be hardcore. Or better yet, think of the movie we could make. If we took like who's good on their bikes in the X Games now? I don't even know. Okay. If we took, yeah, but he's on a pedal bike though. Yeah. If we could take that guy back in time to like the 1800s, and then he was like a spy, and he had to get away from some people, and the only thing he could ride was one of these things, and he actually rode through London on one of these, like if it was Kingsmen, but back in time, that would be a wicked movie. You'd pay to see it.
I would.
Oh, you guys pay to see Paul Blart Mall Cop, so you'll pay to see that.
No.
What? What? Yeah, it looks pretty cool. How was it?
It was, I find, it was really over the top.
Oh yeah? Imagine that. Over the top. Hollywood movie. Yeah. Okay. 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 All right. So what what measurement of this wheel will tell me how far that bike will go? The circumference. The circumference of every circle is pi d. Do I have the d? What is it? 52 inches times pi will get me the answer. Now, when you do 52 times pi on your calculator, you get a giant number with a bunch of decimals, right? You get, and then I say just use 2. 2's enough, right? So, okay, you use 1, no problem, I don't care. Again, okay. Okay.
It's going to be a good week, isn't it, Mr. Myers?
All right. My voice doesn't go louder than this, so I'm going to try and say this one more time. I do not care how many numbers you use. Okay? I do not care. Do you have it now? So stop telling me how many numbers you use when we are doing stuff like this, okay? Back corner. Did you get all that too? Okay. Please notice that the rest of the room did not do that. When 28 people do or don't do something, you should do or don't do that same thing. Okay? Riley. Yeah. So, that was the math you had to do. But that does not answer any question yet, does it? Because the first question wants this in feet and inches, yes? So that is going to be in inches, correct? So when I go to my calculator and I do 52 pi and I get that barf-tastic answer, do I clear it off my calculator? No. Right? Because I need it again. That is inches. So what do I do to get that to feet? I divide by 12. So down here, I just write the 163 is enough to remind me that I need to multiply by 1 foot over 12 inches. So it's divide by 12. So I go to my calculator. Even though I wrote 163, I have the number right here, don't I? So I do divided by 12. And that gets me 13.6 6135, blah, 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 blah. Now, yes, Brianna.
Does it matter if you use the 163 for like all those numbers, or can you just do like 163
Okay. I do not. It'll be fine. Yes, it will change your answer. But when you see what I'm doing, you'll understand why I don't care. Okay? So now I got 13.6, right? Is that feet and inches? No, that's feet and tenths of an inch, which we do not measure in, yes? So I know I have 13 feet and I have 0.6 of a foot, don't I? But I don't need feet, I need inches. So I need inches, so 12 inches goes there, 1 foot goes there, so it's 0.6 times 12, yes? Which is 7 inches. If you have anything close to 13 feet, 7 inches, you have done the math close enough to make me, your math teacher, happy, because the math is the conversions, not how many decimal places you choose to use. Does everybody understand? Okay, so anything around 13 feet, 7 inches. Everybody cool? Does anybody need more explanation than what I have given? Going once. Going twice. going thrice. Thrice is 3 times. Like twice is 2 times. TW. Now, I need my answer in meters and centimeters. Now, I could do this, right? Or, better, I would use this. I can go 13.6 feet, and I want meters and centimeters. So I want meters, right? So it is 0.3048 meters for 1 foot, because that's what I already have, right? So I do 13.6 times 0.3048. And why was I allowed to keep the decimal? Notice I've left it on my calculator. Times 0.3048. Why am I able to leave it as a decimal? Because in metric, I'm going to get a decimal anyway, aren't I? So that got me 4.15 meters. Is that meters and centimeters? No, not quite. It is 4 meters, 15 centimeters. Does everybody understand? Do you all understand why these are the same distance but different measurements? Does everybody understand that? 4.15 meters, that's really 4 meters and 15 1/100ths of the next meter. 1 centimeter is 1 100th, so that's why it is 4 meters and 15 centimeters. Is everyone cool? Excellent. Now, the last question. To travel 1 kilometer, I am measured in meters. What must I do to that 1 kilometer? Times it by 1,000, because I need it to be meters, because I can't compare meters to kilometers. So it's 1,000 divided by what? No, I've already done the 1,000. I did that in my head. 4.15, because I'm allowed to use decimals because I'm working in meters. And I get something like 241. Everybody good? Now, okay. For the little one, it's the exact same thing, except it was an 18-inch diameter, right? So, the circumference equaled pi d, which was 18 times pi to get it in inches, yes? Then once I have it in inches, I had to multiply that answer by 2.54 to get centimeters, yes? Once I have centimeters, I would take that answer and divide it by 100 and take that answer and do 1,000 divided by whatever is there. Right? So let's do that. 18 pi gets us our inches. 18 pi. So it's 56.5 inches. Now, I know that it's more than that, so I just wrote the 56.5 because I'm going to use this number for my calculator, right? And then because I'm showing my work, I know I need inches and I want centimeters. So cm over inches, 1 inch, 2.54, numbers on the top. So I take my number and I multiply by 2.54. That gets me centimeters, yes? Right? Now that, I'm going to write 143.63. That's centimeters. I need it in meters. So I need meters. 1 meter is 100 centimeters. So it's that divided by 100. So I go to my calculator, divided by 100 to get that answer, 1.43. And then I need 1,000 divided by the 1.43 to get 696.21. Right? So does 696 get me that whole kilometer? So how many times do I have to travel? Roll the wheel around. 697 to get the whole kilometer, yes? So even though 696.21, we would normally round down to make it that last kilometer, you have to finish that last revolution. The whole point of the question is to make you think. Do I know by the 11th grade that you know how to round? Yes. But I want you to have to think about the questions, right? If you stopped at 696 and I told you I'm going to pay you when you ride your bike a kilometer, if you counted 696 turns of that back wheel, would you get paid?
No.
No. Does everybody understand? Everybody cool? Okay. I left you, I think, with that as homework.
Yes.
And you were to attempt page 42, but you were to stop at number 4. That's what I think I told you guys. Is that the case? I mean, I can always check on the video, but I'm asking you. Did I? Okay. All right. Pardon me? Okay. So let's have a look at these questions together. Everybody just look at the first one, talk to your neighbor, and tell me what you think should be your first step to making that question work. Take a moment, talk to your neighbor, and if you wish to volunteer, volunteer. Go. Nobody should have done it, because apparently I didn't assign it, so talk now. I know I did, but I also know what I get, right? And 5, 4, 3, 2, 1. Would anyone like to volunteer what they would have done first? Anyone? What? I think you're right. Yes, you should start with the formula. What is the formula for the surface area of a cone? Riley? I know he was. What is it? Pi r slant. Excellent. What should your next step be? Figuring out the slant height. Now, to figure out the slant height, I got a whole bunch of unknowns there, don't I? How many unknowns am I allowed to have if I'm going to do algebra up till grade 10? Like back in the day when you were taught algebra, how many letters did you have in the equation ever? 1. How many do I have here? 3. Because I got that's a variable, and that's a variable, isn't it? Can I get rid of some of those variables? How? I know the radius, so what do I write instead of r? What do I write? Excellent. Do I know any of the other variables, Aiden? The surface area is what? 1,200. So now, wherever I see SA, what am I allowed to write? 1,200 equals pi. Wherever I see r, what can I write? 5 squared plus pi 5s. Yes? Now, I can tidy this up some more. 1,200 equals, what's 5 squared? 25 pi plus 5 pi s. Now, I'm going to cut Riley off at the pass because Riley was the one that said we got to get s by itself earlier, right? How do I do algebra? Now, this is where we get into trouble. 1 second, keep the thought in your head. If I asked you to solve this, could you do it? Of course you could, because you know how to do algebra, which means you also know how to do this, but it looks different. Do, looks, matter. Excellent. Brianna, are you going to volunteer what you would do now?
Yeah.
Excellent. What would you like to do now?
25 plus 5 pi.
Okay, you want to add these. because you see pi and pi, right? Let me ask you this. Think back to grade 9. Could I add 2x plus 3xy?
No.
Why not? Because they're not like terms, are they? So, can I add this and this? No. I like the way you're thinking. You saw the pi, you saw another pi and wanted to put them together. But you're thinking of pi as being a letter, like here. Is pi a letter? No, pi is a number, isn't it? The only reason we write it as pi is so we don't have to write 3.14159278, blah, 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 right? So really, this is a number. It's not a number and a variable. You cool? So I like the way you're thinking, and sometimes we can do that, but we can't do it here. What would you like to try, Aiden?
Divide pi from 225 and 5 pi s.
So you want to take pi out of there.
Yes.
So Aiden is saying if I divide that by pi, pi will disappear from this side. And if I divide that by pi, pi will disappear from there. Is that okay? Why did you say divide, Aiden?
Because if you have two things next to each other, then only indicates that you're supposed to multiply them together.
This is saying multiply, and we want to reverse engineer, don't we? So we got to get rid of multiply, and to get rid of multiply, we got to divide. So that means I got to divide 1200 by pi, don't I? Does everyone agree? So what's going to happen to these pi's? Gone, gone. And I'm going to rewrite. 1,200 divided by pi equals 25 plus 5s. Does everyone agree? Is everyone okay with that? Okay. Now what should we do? What would we do over here to get rid of that 7?
Subtract 25.
Okay, I see what you're saying. I said, what would we do to get rid of that 7? You said subtract 25. You're taking the lesson I'm trying to teach you over here and already applying it here. Jack says he would subtract 25 from this side. Is everyone okay with that? Because we want it to disappear. We want s to be by itself, yes? So what do I have to do to this side? 1,200 divided by pi, and then I subtracted 25, didn't I? Equaled what? 5s. Now, how can I get rid of that? Divide by 5. What do I have to do over here? Divide everything by 5. Now, what happens to those 5s? They're gone. So what is left here? So s equals 1,200 divided by pi minus 25, all of that divided by 5. Now, this is ugly, isn't it? That's a mess. Because this is saying 1,200 divided by pi minus 25. All of that then has to divide by 5. Right? If you got to there, am I your happy math teacher?
Yeah.
Very much so. Very much so. Okay? But if we were doing this question on a multiple choice test, that's probably not going to be an answer, is it? I'm going to want you to punch into your calculator, aren't I? And that's where a lot of you fail. Here is why you fail. You don't fail in your knowledge. You fail in your ability to punch it into a calculator. So what I like to tell you, the same thing I tell you every time, have an idea of what your answer is going to be. Okay? Let's do that. What is pi very close to? Closer. You can do stuff in your head with a 0.14. It's 3, isn't it? What is 1,200 divided by 3? 400. 400 take away 25 is 375, right? 375 divided by 5, 75, right? So my answer is approximately, that's what that symbol means, 75, without going to my calculator. Now, when you go to your calculator and try to punch that in, if you get something that isn't close to 75, have you done it right?
No.
Would you hand it in to me?
No.
No. So now the question becomes, how do you punch that into your calculator? Aiden.
7,200 minus 25 divided by 5.
71 is the right answer. 71.9 or something. Great. So, to punch this in, what are the keys to remember? Well, you got to bracket the top. So, I'm going to write in green what you would hit. Bracket 1,200 divided by pi, bracket, minus 25. Actually, to do it this way, to do it Aiden's way, you actually need two sets of brackets. No, you could do it with one. 1,200 divided by pi minus 25, close brackets, divided by 5. And you will get 71.9. Is 71.9 pretty darn close to 75? So are we happy? Excellent. Now here's the problem. You guys refuse to do that step. And because you don't do that step, you hand me in gobbledygook. If I asked you what the answer here was, I would have heard, a few people would have gotten 71.9 because they would have been good with their calculators. But in my other class, I heard 200 and something. I heard 500 and something. I heard 4. Just 4. Now, everybody understood this, the algebra. But the vast majority of the class couldn't make it work on their calculator. Right? I'll say it again for the 100 billionth time. This is not calculator 10. This is math 10. Okay? Everybody cool? All right. Does everybody see how useful estimating is? I hope you are starting to believe me. There's a reason we do it. All right. Let's look at the next question. The volume of a cylinder is 500 centimeters cubed. So there's a number, and I need the radius. So what should my first step be? Nick knows. Nick says write down the formula. The volume of a cylinder is pi r squared h. Because pi r squared is the base, isn't it? Because the bottom of a cylinder is a circle. Do I know any of those numbers? What do I know? I know the height is 20, and I know the volume is 500 equals pi r squared times 20. Now, what's my job? That was a good one. Whoever said that one. I like that one. We're going to divide by 20 because we want to find r, don't we? And if we divide by 20, we'll get rid of the 20. What else should we divide by? Pi. Because pi, then I can get rid of them both in one step, can't I? So if I divide this side by 20 and pi, what do I have to divide this side by? 20 and pi. So now, 500 divided by 20 pi equals r squared. You guys are smart kids. Opposite of add is subtract. Opposite of divide is multiply. What's the opposite of square? Square root, right? So I would take the square root of both sides, and r would equal the square root of 500 over 20 pi. Is it now time to estimate? Okay, I'm going to estimate in red. What is 20 pi almost? 60. 20 times 3, yes? It's about 60. Agreed? What number is close to 500 that will play well with 60?
600.
600.
Wow.
And I want the square root, yes? What is 600 divided by 60? 10. Square root of 10. What perfect square is close to 10? 9. So this is close to the square root of 9. So our answer must be close to 3, yes? Now do we go to our calculator? Yes. So again, you have to know how your machine works. On my machine, I can punch this in exactly as I see it. Some of you have to work backwards. Everybody try. Your answer should come out to close to 3. And if you do it right, your answer will come out to 2.82. 2.82. Is that close to that? Now, stop. Is it now time for a quick calculator lesson? Now that we've talked about all the algebra and we've talked about the estimating, should we now talk about how to make that work? Is there anybody in the room that could not get that? Just 2 of you? Okay. Do you have calculators like mine that show you what you are doing? If you push the square root button, does it put it on the screen? Yes? Both of you? Okay. So the easiest way to do this is not to try to do it all at once. The easiest way to do this is to start in the middle. So what math is happening there? 500 divided by 20 pi, yes? Somewhere in there I need brackets. Where? 20 pi. Anytime you have more than one math operation, you want to use brackets. So you on your calculator, and Brianna, you on yours, will need to push 500 divided by bracket 20. Now I can just go 20 pi. You might need to go 20 times pi. I don't know about your machine. Close brackets, hit enter. And then you should all see 7.95, do you? Do you, Brianna? Now, I need the square root of that. So on my calculator, I get square root, there it is. And 7.95 is the last answer I got, right? So I use the answer key, square root of answer equals, and I get my 2.82. Got it?
Yep.
Brianna?
Yeah.
Excellent. Again, Tasha, do I give you full marks for that?
Yeah.
Yes. Okay. If you can't do that on your calculator, then break it down even further. Find out what 20 times pi is. Go 20 times pi. Then do 500 divided by answer. And then do square root answer. Okay? All right, let's look at the last one. What should we start with? Formula. Volume equals 4 pi r cubed divided by 3. What do I know? I know the volume is 7,602. 4 pi r cubed divided by 3. What's the first thing I should get rid of? Jack? The 3. How do I get rid of divided by 3? Multiply both sides by 3. Cancel, cancel. And I'm left with 4 pi r cubed equals 22,806. Everybody okay? Nothing tricky there, right? Now, what do I need to get rid of? Jack, you might as well finish it.
4 in the pi, so you divide each side by 4 pi.
4 pi, 4 pi. So now I've got 22,806 divided by 4 pi equals r cubed. You guys are smart kids. If you get rid of squared with square root, What do you get rid of cubed with? Cube root. A cube root looks like this on your calculator. Almost all of you should have that button. If you don't have that button, I will come and show you what the button you are seeking is. You do have that button. You should have it, Carlos. Okay. If you don't have a cube root button, look for this button, X root. If you have that, then you need to push, Okay. Now, stop. He said stop. Is now the time to estimate. This is close to what? Our estimate, I'm going to do in red. What's this close to? 12. What number is 22,800 close to that would work with 12? 24,000 divided by 12 equals r cubed, yes? What's 24,000 divided by 12? 2,000. Right? Equals r cubed, yeah? Everybody with me? What's the cubed root of 1,000? 10. But I got 2,000s. So my answer should be around 20. But I got to stop and think for a second. I made a pretty big jump from 22,000 to 24,000, didn't I? It should be smaller than 20 because I raised this, right? So now we check. How do I do this? Well, I get this number first. Where do the brackets need to go? Around 4 pi. And I should get somewhere in the neighborhood of 18, 19 point blah, blah, blah. Should equal r cubed. See if you can make that happen. Try to make 22,806 and 4 pi divide to get that. Was everyone able to do so? Okay, now we come to a new problem. So I go to my calculator, 22,806 divided by bracket 4 pi. It's 1814. Sorry, guys. 1814.8 is 1815. Everybody cool? Now remember, we said, what was our estimate? R cubed would be around 2,000. Was R cubed near 2,000? So are we on the right track? Yeah. And then all we got to do is cube root this. Now let's pretend you don't know how to cube root on your calculator. If you get to there and you wrote cube root of that, would I be happy as your math teacher? Over the moon. Because this is the math. Not knowing how to use your calculator is not deserving of punishment. Everybody cool? Now, if you were going to do this on your calculator, again, you need to know how your machine works. How many people have this button, cube root? There's a 3 with the radical sign. Were you all able to make it work? The answer is around 12 something. 12 point, I don't care. 12. Everybody good? So, is there anybody, one sec, Brianna, that doesn't have the cube root button and only has the X root button? Everybody had a cube root button? So you have the X root button? Bring your calculator here. Quick like a bunny. You don't have to. I said quick like a bunny. I don't care how you get here. You can fly if you want. Really? You don't have the cube root button?
Oh, I didn't see that.
Yeah, surprise, surprise. That's why I make you walk to me. So the next time you ask, you look first. Brianna, what was your question? I would love to show it to you, but I can't hear what you're asking me. It's frustrating, isn't it? Try being the guy up here. Yes, Brianna? You have this big one? Oh, yours lives in math. Hit the math button, and there it is. See, it's number 4. So for you, you would hit math, then 4, and then C cube root, and then you just punch in what you needed. All right. Is everybody good? Okay. That's algebra. Now, turn the page over and tell me what's weird about number 4. Because you can't do it.
There's a projectile, so the projectile will drop depending on how much weight the projectile has.
I have one number, don't I?
There's 4.9 squared and then 12.
What number or what letter can I put that 100 in for? H. So what I would get would be 100 equals negative 4.9 t squared plus 12t plus a, correct? I want you to find me a. So that means get a by itself, right? So how do I get rid of this negative 4.9t? I would add it. So plus 4.9 t squared. So I come over this side and I've got a 4.9 t squared. How do I get rid of this plus 12? Minus 12t from both sides. And what was already here? Plus 100. Is a by itself now? Now, what is weird about this? There's 2 t's, right? Do you guys have in your math repertoire any mathematical tools yet that allow you to work with 2 letters? Because I can't add them because they're not like terms, right? So can I isolate them? No, because how do I isolate? I would have to divide by t, right? So if I divide this guy by t, what do I have to do to everything else? Divide by t. So that moves t back over here, doesn't it? And I don't want t over there. I need a by itself. Does everybody understand? You cannot do this question. So why, Mr. Myers, did you give us this question? So you can learn this move. You can move a whole thing if you keep it as a whole thing. Do you understand what I am saying? Everybody with me? I just took this negative 4.9 t squared, the whole thing, and added that whole thing to both sides. Does everybody see? That was the point of that question. Jack, were you? No, you just were shifting. Never mind. Does everybody have the lesson from there now? You can move whole chunks of stuff. Everyone cool? Up until now, you're used to moving one thing at a time, right? Now we can move whole chunks. Everyone's good? All right, let's look at the next one. What's weird about 5? It's got 2 variables. And what don't I have? I have no numbers, do I? What does solve for x mean? Find x, which means x has to be what? Find x, which means x is isolated. Now, can I isolate x when I have no numbers? Yes. By doing what? Does math change when looks change? No. So let's have a look at this and I'll show you what I mean. If I'm going to solve for x, x has to be alone, yes? So is there some math in the way of x being alone right now? What is one piece of math that's in x's way? Square root. How do I get rid of the stuff I don't like in algebra, Sam? I do the opposite. What's the opposite of square root? Square. So if I square this side, does that get rid of the square root? Okay, so what would be left on the right? 2x plus 4. If I do something to one side, what do I do to the other side? Same thing. So what's going to be on this side? A squared. Everybody cool? Okay, now what's in the way of x being alone? And? 4. Which one would you get rid of first if we were in the 9th grade? The 4. How do you get rid of the 4? Subtract 4. So what's left on the right? 2x. What do I do over here? A squared minus 4. Because I can't put a number in for a squared, can I? So I got to leave it. Now how would I get rid of this 2? Divide by 2. So what would be left on the right? And what would be over here? A squared minus 4, all divided by 2. And that's the answer. Now, prior to today, some of you did not know you could do this. Move whole chunks. I know, you've done all of this last year, and yet you guys still sat here and said, Mr. Myers, I don't know what to do on this question, even though you've done it all already. Because you guys take 2 months off. And then, if you have a semester break, you've actually taken 6 months off, which is why our timetable is stupid. If we really cared about you guys, you would go to school for 6 weeks, and then take 1 week off, and then 6 weeks and 1 week off, all year round. Then you would forget nothing. But nobody is willing to do that. Because nobody's asked the teachers what would be a good idea. The problem is, if you can't turn off all the lights in the school for 3 months of the year, you have to pay to keep them running. And that costs money. Summer, Christmas, and spring break save schools millions of dollars because they can turn off the lights in the heat. That's really why we still have long breaks. It's not about you guys or us. It's about saving money. Don't tell anybody, we know their secret. Now, yes. Now, these are here for one last reason. All of you are very good at algebra when it looks like this. 2x plus 7 equals 14. You can solve that in your sleep. Once I give you this, you actually say to me, oh my God, Mars, I don't know how to do that. I know, Aiden, it's weird, but they actually say it. Kids look at 6a and say they can't do it. If I gave you 2x equaled 14, you would know to divide by 2, right? Because you do the opposite of what you see. Well, what do you see here? X divided by 4. So what do you do? Times. What happens to those two 4s? They cancel. And I get x equals, what do I got to do to 23? Multiply by 4. See, you just said divide by 4. Yeah. And the answer is 92, right? Okay. Now, how do I do that one then? Jack?
So what I did was I took 60, I divided it by 5.
Right.
I got the number and then I multiplied
Yep. So Jack went straight to the shortcut that I taught him last year. But the shortcut only works if you know what's really happening. Do we want x as a denominator or do we want x as a numerator? Numerator. So it's in the wrong spot there, right? So it has to move. How do we move stuff in math? By doing algebra, which is doing the opposite of what we see. So what do we see there? So what do I do? So once I have x and x, what happens to them? They cancel and I get 60, right? What do I got to do to this side? Multiply by x, so now I get 5x equals 60. Then I would divide by 5 and x would equal 12. Once you've done that once, that should give you the shortcut, right? When the number is on the bottom, what did we do? 4 times 23. When the number was on the top, what did we do? 60 divided by 5. But you don't get the shortcut until you do the algebra. Okay? All right, now listen, you're in class for another 25 minutes. Listen to me carefully. On page 44, your measurement review starts. Every single question in there you know how to do. But there are some tricks that require you to think. For example, look at the very first question. Have you ever seen KL and CL? No, because that's kiloliters and centiliters. Do we use those? No, but do we use kilometers and centimeters? And is this metric? So do metric rules apply no matter what the second letter is? Yeah. So do you know how to do that one? Yes. The next problem you will face. Milligrams and ounces. If you look on your formula sheet, you do not have milligrams to ounces, but you do have grams to ounces. Once you have your grams, do you know how to transfer everything in metric? Yeah, because you can go meter to centimeter. So can you go gram to milligram? Yes. And the only other warning I'm going to give you is this. Everybody turn to page 45, bottom left-hand corner. Bottom right-hand corner. That is incredibly difficult. That is why it is not part of your homework. Some of you are going to go home and Google this question, and you're going to copy it all out, and you're going to come in tomorrow and show it to me and expect 10 gummy bears. I will give you those 10 gummy bears if you can explain why it works. Now, when you go home and Google it, 1,000,000 pages will show up. Some of you will say, Myers has checked the first one. I'm going to use the second one. I've checked it too. Then some of you are going to say, Myers is going to check the first 10 because he's a super nerd. I'm going to use the 11th. By the time you get to the 11th page on Google, they're just repeating the first page.
That's why you gotta go to the second page, at the very bottom goes all the way.
Oh yeah. Hey Jack, does math change with looks? It's going to be the same damn math the whole way, isn't it? So then the kid says, doesn't matter, I still got gummy bears. Yes, you did. You spent an hour looking it up and learning how to explain it for 10 gummy bears. You spent an hour of your life learning math. I spent 5 seconds to give you 10 gummy bears. Who won?
You did?
Damn right. Feel free to Google all you want, but if you want those gummy bears, you're going to need to explain it, and then you're going to have done a crap ton of math anyway. So, here's what's going to happen tomorrow. At the beginning of class, I'm going to walk up and down the aisles. I'm going to look in your books. There are something like 20 blanks you could fill in. So let's, there's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 blanks. If you have 9 of those blanks empty, what is the best mark you could get? 50%. So when I ask you for your score on your test on Wednesday, if you say anything more than 50%, what do I know? You're a liar. And you do not want to be branded as such by me. Do you understand? So the first thing I'm going to do is walk up down the aisle. And I'm going to have my little checklist there. And I'm going to check how many blanks you've left. If you've left 1 or 2, that's pretty awesome. That means you could get a score of about 90% if you did everything else right. Then we're going to mark it in class. And then on Wednesday, you're going to write the score you got on your test. Then you're going to hand your test in to me, and I'm going to record that on checkmymark.com. Okay? We're going to do that for every unit. There will be a review and a test. The review is the assignment. If, after a couple of units, I start seeing the following pattern, 90%, 87%, 94% on all the reviews, and 20%, 21%, 38% on your tests, what am I going to know?
Somebody knows how to use Google.
Which is code for
You're dumb.
you're a liar. And you don't want to be branded as a liar. Do I make myself clear? The reviews are actually more difficult than the tests. I know you get your books for the reviews, but it's still harder work. Which means if you are getting those great marks on the reviews and bombing the tests, something is wrong there. And is it wrong with this end of things or that end of things? That end of things. Because you're not taking your work seriously. Clear? Go.